Yeah, apparently epsilon is not being changed. This is partial derivative relative to C1 and epsilon 6. Which means you should get 4 evaluations of f, and I only see 2. Well, just the first coefficient. Which coefficient is that? This looks like the first coefficient. So that would be C0, not C1. This is C1. Huh? No. It seems to be changing the wrong coefficient on top of that. It's not changing the coefficients, which are just stay all 0. So I'm just testing I is 1 and j is 6 now. The rest I skipped. Yeah, I think I just should run through this with the debugger. You can't print it. The epsilon index should be set because we do have an epsilon, and that's the 1, I think. No, the 6, of course. Yep. Yeah, so it's not empty then. But this is also not empty. Hopefully, let's see if we can print that one. Also not empty. Okay. All coefficients are copied, and all epsilons, which are all 0 at the moment. No, don't care much about the sign yet. It would be nice to see what size says. So I should return 2 because we have both epsilon and one of the coefficients. So we have 2 variables. Oh. Yeah, that's wrong. The tertiary operator has a very low precedence, so you have to almost always put them between parentheses. Like that. I'm just going to run through it again, I think, even though now might work. So this is still 6. Therefore we add 1 for the epsilon, and this count should be 1. Yep, so now the size is 2. Returns 2. The modulo of that is 0, so it's not equal to 1, therefore we return 1. Which means that if everything is empty, we should use a plus. And the mask is 1, which is just the coefficient. We want, well, no. Yeah, that's what I mean. So this is the wrong coefficient. It was changing coefficient 0. And we should be changing coefficient number 1. So they should have been 2. So mask has been initialized wrongly. Let's fix that first. Yeah, what a nonsense. Okay, my dinner is ready. Or not. Oh yeah, this used to be index. I changed the index back to an int. So now it's no longer a mask, it's just an index. So I have to use index to mask. Break again here, run again. Next, what begin permutations? Yeah, run again. Next, step. Next. No, still 1, of course. And now mask should be 2. Very good. Now we get the unused mask is the inverse of that, and then of course, because this is not true, we don't do anything, really. What a bullshit. More bugs. 149. It's the opposite. We just set the bit already, so we have to reset it if it is unequal -1. The very idea. Where's my breakpoint? Yeah. Absolutely no idea what's happening. Apparently this is now highlighted. No. Guys, you know we have 2 bits not being set in the unused masks. Okay, they are used. Now finally we should have something that makes sense. The result plus is sign times evaluation. So this is the first evaluation. Then I get next permutation, which runs over L. Well, there's a loop of 2. So first we reset everything that is being set, and there's nothing set now. This is 0. So the for L is 0, they should not doing anything. And then we do an OR, and then we do an increment. Now the first bit is set. And we reset the unused mask again. And then we go to the top of the loop. Okay, yeah. So now it should add delta to whatever is set, and the first thing that is set is the coefficient, so not this one. This one. Yeah, so we add delta to coefficient 1, which is correct. For the rest, nothing. Break, current mask. Why is that returned? Yeah, to test if it is 0. Yeah, whatever. Let's just run it. Okay, no, the result is 1, as it should be. So this is correct. Let's see if it now works for the whole thing. As in Let's remove this. Yep, perfect. So this is the just the derivative, calculating the derivative. So you get a machine epsilon in front of these things as this the error term. This would be the exact value, and then these are the epsilon times something. And then, as expected, we have a 2 here and a 3 there. Okay, I can also test the cubic. Although that will work as well, of course. Yeah, that's also the same. So we have epsilon 0, and then we get those extra, and then those extra, and then that one extra, as before. Now then back to the Newton one. I don't think that makes sense. No. Oh, I already know why. I mean, there's something very wrong here. Namely, I commented out this part. No, that's not true. It's nonsense. This is just printing. And the decomposed float doesn't work. Because you have to multiply twice with the derivative now, instead of just once. It's even worse. It's just ridiculously different. I need a second loop. Another loop. The third loop. We want to take the double derivative of two different coefficients now. And an epsilon. Yep. And then the decomposed flow should work. So I'm going to multiply twice with the derivative, which is a constant. So, wait a minute. Why? this part should be removed at the very least, I think. My code is not flexible enough. Yeah, no. Let me. I'm gonna take care of my dinner. I'll be right back. Oh God, shoot. Already start with fireworks. Yeah, I'm definitely having a problem here with I'm not really able to differentiate relative to yet another coefficient. I mean, that would be a lot of changes. Just kind of not working. Damn it. think I have to start over with a new file. Of course, this is not flexible enough. I wonder if I can use my symbolic. Let me think. So what I have is an arbitrary function of many variables, which would be this one. It's not just a function of x, it's also a function of epsilon and c. And then I need a program to find alpha values in an attempt to write that function as that same function where all the epsilons are 0 plus a summation over all the different epsilons times something. And to do that correctly, I should write this in a way that well, covers everything I'm going to need. And I guess I might as well make x a variable and c as well, and just all of them are just variables. Just dump them all in one class, I think. And then clearly I need powers. So it's a product of variables to some power, which I already have as symbolic. So it looks very much like my symbolic library. Except that now I have to figure out what the constants are for each. Plus, I need to, I think, well, I'm sure I have to evaluate those things. What? What is that GLPK doing here? Probably need eigen though, so I forgot, but so symbol is separate. Let's not include Cairo when we are then. Yeah. Let's see. Cairo window. Yeah, this is no documentation here, of course. I've got how to use it. I have to skimble something. Private constructor. Oh, yeah, I have to use realize. So it's auto reference realize, calling that on the symbolic. Auto X is, well, I need a reference. It's called the, well, I'll forget const. Symbolic symbol realize. X is X. Can't argue with that. However, this symbol now, yeah, it has a double as value. Damn it! So I really need MP real value here. So either I can't use this, or I would have to change the whole symbolic to a template. And I don't think I should do that until I'm sure that it's what I need. That would be a lot of work. Yeah, it would sure be handy though, for the printing mostly. I don't need that much, I would say. I need symbols, of course, and then I need, yeah, I need sum and products. And power, okay, yeah, and constants, yeah, it's still a lot. Maybe it's not as bad as it looks actually. I mean, for example, here we just have a one double here. It has a double value and you can return it. And then if, for example, well, you can assign it. So we're talking about, say, the products. Just evaluate as it. But yeah, that means that both arguments must be templated value. Which means that absolutely everything else must be. No, these are expressions. Expression as a virtual evaluate. Yeah, okay. So expression must be a template. Ugh. Definitely everything has to be a template. But for the rest, it doesn't seem to be very much work to turn it into a template. Maybe I should do that. Let's try to do it with just double for the moment, and then if it becomes something, then I can always change this into a template. My music is complete shit again. pretty sure all my epsilons are also symbols, right? Sometimes I want to give them a value. So for example, I can well, you might as well do it with x now. So x is 42. That should compile. And then we can evaluate it. And like I said an hour ago, when was it? Hi Dennis. I wanted to make all my variables, that is the x, the epsilons and the coefficients, all just the same thing. As in, let's make an enum. Variables x coefficients and yeah, and any number of epsilons. Currently I had 10 or something. Yeah, the need for 10. So put them a little bit more like that. 5, 6. Wait a minute. 7, 8, 9, 10, 11, I think. That's what I use so far. So look, we'll make an array of whatever this thing is returning, the symbols. It was returning a const reference to symbols. So symbolic, simple. Well, you can't store references here. So I'm just going to store pointers. Kind of dangerous in terms of lifetime, but yeah, we'll have to. And then one for each variable. These are my variables now. And then I definitely need a toString for my variables. So just standard string toString. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, let's test it. Oh, this is macros, I think. Utils macros. And let's just try to print E3. That's not smart, of course. If you know I add one here, say E12, then it would, well, I would assert that wouldn't be as bad, but I would rather have it not compile. So I should just use a case here. The only reason. So now we add E12, then it would still say that E12 is missing. It's probably better. So yeah, we now can print E3. So we can now fill this array by looping over all variables, v or whatever. No, I is less than the number of variables, plus I. Variables I becomes, and then yeah, this returns a reference to stuff. Just turning the reference into a pointer. Definitely should work. And realize takes what? Realize takes realize name. Name there, string const reference. I guess, or if it does it here, then it probably does it also for symbol. So this is just simply toString and then the enum. Oh, so I need to run over all the enums then. Yeah, variable. So I want to run over all the enums. Shit, I have something for that, but I forgot. Does this not work? No, wouldn't that be nice? No, it doesn't work. If I would write something like that, it would have the word enum in it, I think. Enum. Damn it. Surely I have something like that. Maybe under debug. GWS. Also not. Yeah, it is impossible to find. This is using a magic enum. Don't want to use magic enum. The only thing absolutely the only thing I have to that I can go on right now is a vague feeling in my head that I think that I remember that there is something that allows me to easily run over all enum values. And it feels like it's true. But then why can I not quickly find it? Maybe it's part of a project and I never put it in the utils. That is possible. But I don't know what to grab for. I don't think this is mine. This is mine, though. Yeah, that's that dictionary thing again. So it's using a magic enum. Damn it. I think it would have to be something involving a static cost, definitely. And it would have to involve an increment. So not this, it's not here. Okay, I give up. Can't find it. Let's do it the stupid way. I'm just going to use an int for a loop variable. Yeah, less than. And then turn that into variables enum. Okay, let's print one here. Let's say two variables, variables E3. Yeah, wait a minute, that's a pointer. That's not working anymore. To dereference the array. So yeah, so now we have all the variables, sorry, all the symbols in an array. But yeah, if I want to really work with that, it's kind of annoying to type this long thing, right? Plus now I have two things with the same string for debug output. The enum and the symbol. It would probably be more handy if the short thing, so the E3 here, is not an enum but is the symbol itself. I could make this a clause. I'll just make this an enum clause. Oh god, not that again. That's nothing to do with this stupid beep. I mean, I want to keep the C0 here, but now we have to put variables colon colon in front of it. But if we do that together with the AI case return, then it gets printed, and I don't want that. So we need to do something here using such that the C0 still works, even though it is an enum clause. And I'm pretty sure I did work it out somewhere, sometime. Nobody knows, of course. Or maybe it should be also called toString. So this thing just prints orientation in front of it. It's not what you want in this case, of course. Nothing, really. There's a lot of strings here. Oh, no, it's not that much, actually. There we are. Simply using enum, the enum. Apparently that works. Well, I remember I had a hard time figuring this out, aka I couldn't, and then someone helped me on IEEE. So if you just do using enum, then you can access the enum clause by name. Good to know. But now it doesn't know anymore what E3 means, because I have to type variables E3. I'm not going to do that. Instead, we're going to create a symbol. Shortcut, I guess. As a reference, E3. And I can just use E3, which is then the symbol. It's called count, I think. variables is not implicitly converted to size type. Oh, now it's an enum class. It doesn't convert automatically anymore. Yeah, that is such annoying that I'm doing that with in a different way, I think. To forget the count here. Just add it explicitly here, which is a little bit more error prone. Because now I have to type the last element specifically. Well, maybe not. You know what? I'm gonna use count here anyway. So I can just use count here and then not add anything. I can make it a const expression. It has to be a const expression because we're using it as the size of an array. While we overloaded something on variables. That's majorly suckage. Could add costs, but let's add explicitly something that is human readable. You have to convert that one to an index. And we work with ints to index variables. Variable. Turn static cast int variable. So the enum class really resists being used as an integer, but eventually we're going to compile and it prints E3. Yeah, still. Yeah, blue. So now we have to add this for all the other variables, so we can keep working with it. Which then is the kind of code duplication. So I would do this in the same. Let's. I don't know, why not? You know. Well, why not? Because I have to look it up again. I did something in the Linux viewer where I use macros to do this. Then, so we define a macro with the macro itself just is a list of all these names, and you define a macro that then produces the whole block. Forgot how I did that, but then you get a block here, which is just the name itself, and then with a case return wrapped around it. And now here again to define the symbol names with a certain name. Let's see if we can figure that out, how that was done. Pretty sure that was done in the Linux viewer. But where? Somewhere in source, I think. Probably Vulkan. No, I really don't know anymore. But hey, it has the word for in it. I'm sure of it. Or not. Okay, we have a look at my dinner because I didn't hear the beep. What? Okay, what happened? Completely cold again. Let's hope the bacteria are dead now. Okay. Okay, that was stupid. Why? I'm doing something not good. Somewhere. How the hell is that possible? I think that's the stuff. So we did find it. Okay. Yeah, maybe something like that. Remember something else. Damn it. Yeah, I don't know. See, this is all XML RPC specific, and it's the only thing I can find. While I'm very sure that I had something that is not related to the XML RPC. I don't know. It depends on so many things. If you're no longer a kid, then you'll never get good, in my opinion. Really good, I mean. Although I started young, but I was not learning C++, of course. I'm talking about programming in general. So if you already can code in some other languages and you started as a kid, so it's just the only thing you really need is syntax and stuff, then it depends on the company and how badly they need someone. Some companies understand that students don't know anything and they just have to train you themselves anyway. So they mostly look at talent. So there's a very smart guy who already coded in a different language for many years. And yeah, and I would say six months C++ would be enough for you to be hired by someone, somewhere, if you're lucky. But then you can't really code. You just still have to learn that. You go into company and you have to learn that while working there, as it were. I'm getting so sick of this. Let's give up on finding it. I'm just gonna reinvent the wheel, I'm afraid. But looping over elements of a macro, and it's not that simple. I don't even know how to do that from the top of my head. Actually, I think the trick was you make a list of... Okay, I have a better grip now. It's still just this data type stuff. These are members. I want to see, but I know I have something where I just a long list, not just two. These are just class members. Okay, I'm gonna try it. So I think that the trick was you just have to literally list it. So we're gonna do define for each variable, call it v. No, wait a minute. We're passing in some macro x. And now we just repeat that macro for each variable. And that then only works if x is actually a macro, so we have to define a different macro. Let's say I'll call this declare. I really have to spy in how this worked here. Damn it. Now there's a list. That's what I know. Call a list. Okay, so here is an example. It says for each something and then x. And then we just repeat x a lot of times. And yeah, then I still need where this thing is being used. Where is this used? Being used here. Okay. And then we call that with something like this. Dude, the question now is where the hell is that going? Nowhere. Oh, here. Yeah, so that's just some macro which takes variables that it needs and then constructs from that the string that we need. So we have the declare. No, let's not use a prefix, but I can use the declare. Declare variable. And then I think I just get the name of the variable. Not multiple things. I mean, that's the only thing I pass here. With just one. No, wait a minute. Later I need. No, I don't. So that's what we're gonna need here. Just the name and then a comma. So then I should be able to do this, replace this with for each variable, declare variable. And then here I want to do for each variable say add the case return. Yeah, might as well, that's almost the same thing. It's adding a semicolon. I'm not sure the semicolon even needed really. But let me think. It might be needed. Let's see what AI case return is. Yeah, it's a do while loop, so we need a semicolon there. Okay. And then we can add this one as well. Declare symbol name. New member name symbol in variables. Oh, I typed symbol instead of name. Such an idiot. It's a namespace. redefinition of x. Previously declared here. Okay, I already have an x here. Yeah, completely true. Like literally twice the symbol x. Good. Should be able to do something like epsilon 3 times let's do times c0 times c3 times x to the power 3. I have to put powers between parentheses, unfortunately. And I might even be able to add a constant in front of it as an integer. But yeah, this is written to an O stream, so everything has to be between parentheses. And there we have it, the formula. So now I can say make my Newton thingy. So the semicolons are already included here, but I'm adding another one because otherwise my indentation didn't work very well. So I want to have a function, right? So I think you have function in symbolic. Let's see how that worked again. Function. We can realize a function from a definition, I guess, and then give it a name. Yep. So also here we have auto reference. Let's call this F. That was like that. Then we use this expression here as the definition of my function. It just prints F. I thought there was a way to make it make it print the definition of it. Have a look. So function. Print, yeah. IO manip full def is full def. Well, nice that there's documentation here telling me how to set this thing. With IO manip full def is defined here. I guess this is it. Just tried running full def. So we have custom IO manipulators. And then you get the full definition of f instead of the name f. So we can say here, for example, the f of well, there is an x in it. Right. Now let's make the actual thing. To do it in steps, right? So I have a cubic. Let's call this a cubic. The cubic is, well, is that called f? I think the cube is called f, really. Yeah, well, okay. Let's call this one f. So theoretically, it's like this, just a cubic. C0 plus C1 times x plus C2 times x squared plus C0. And it can make the derivative. I'm going to call this one f. So df is the derivative of f. Derivative. I'm not sure if you have to specify relative to which variable, probably. So let's have a look. This is a function. Better go to function. Yeah, derivative. Yeah, you have to pass a symbol. So the derivative relative to x. And then let's print it. df. Well, it's not updated, but the derivative is, yeah, I can print the name as well. Let's do that. Instead of doing this, we print df by name. So the derivative with respect to x is this, which is correct. You know, it was c3 times x to the power 3, so the 3 comes in front of it, and this becomes x squared. Same here, 2 in front of it, and the c0 is gone. And I can define, let's say, g. As x minus f divided by df. That would be Newton-Raphson. this is like a literally f. And then the divided by is to the power minus 1. So this is the derivative. And all of that is subtracted from x. But our formula is also depending on all the epsilons. So now you have something that depends on all the C0s, but we need something that depends on all the epsilons. If you want to evaluate it, that is. Yep, let's have a look at how the epsilons got in there. The canonical way is to do an operation to two floating point numbers, either a multiplication or an addition. And then the result is multiplied with 1 plus some machine epsilon. So purely for evaluation purposes, we could use this, but then you get an incredibly big formula in the end. And in the end, I just want to ignore all the epsilon times epsilon things. Might as well do that immediately. And this program figured out what that is. So instead of really calculating them like that, I think I'm going to go straight for the simplified versions already. This is the derivative. Wait a minute, is this a derivative? Well, it looks like a derivative. Still annoying enough, but then it can no longer use derivative then, because we get all the epsilons involved. And in the end, we're going to calculate the derivative separately. So, yeah, really, I just need to make a new function. Just use this as name, I guess. Oop. That would be including the epsilons. And this one, yeah, also comes with the epsilons. So that would be the, I guess, 0 times that plus... yeah. Okay, why am I getting 2 epsilons multiplied here? It's not what I want. It should never happen. Well, because I typed that in. This must be a plus. Well, at least that is printable. We can evaluate it as well. Better yet, I can just take the derivative now, instead of having to rely on 256-bit precision numerical guesses. For example, we want to take of this thing the derivative relative to some epsilon and a coefficient and another coefficient. So for example, let's take the derivative of, well, pick a few things. So dg, and then we take the derivative relative to, so 3 even. D, let's say epsilon 1 or something. And dc2 and dc3. Hopefully that gives me something. Well, it's gonna give me something if there is a term that has epsilon 1 and c2 and c3 in it. Let's have a look if that's the case. What did they say? Epsilon 1? I don't even see a single. Oh, here's a single epsilon 1. Yeah, it's not that easy, is it? Okay, there is a C2 and a C3, but not sure what's going to happen. But okay, getting 0 would be something too. I don't think we get 0 and then it works. Let's just try it. So I want to get G and then the derivative with respect to E1. and C2 it says here, and C3. We just have to print that, I guess. What is that? What the hell? Look like a bug in symbolic. Is no good. Oh, that sucks. Let's just take the derivative with respect to E1 only first. Yeah, that ain't helping. Really? 0 times? That thing is apparently not bug free, unfortunately. Okay, 0 times to the power minus 2 times, so this is 0 times, and then again that's all of that is 0. So the only thing that would be left is this part then, which looks like it's not 0. Let's use Octave to figure this one out. Let's see what it should have been. Rather. This is done in a format that I can just copy paste it into Octave. That is nice. This whole thing. Which one? E1. How does it work again? Div G1 display simplify. Nah. That doesn't look simple at all. No, it looks like it is the same thing, however. So what I said was a 0 should have removed all of this, right? So what is left is this part. So my other answer is this. What? Yeah, that's the exact same thing as what we have here. So the only problem seems to be that this 0 is not recognized as being a 0. That's strange. I think this is the derivative relative to E1 of the denominator, which doesn't have an E1 in it. But yeah, how the hell can that not be 0, man? The denominator would be df. I mean, if I just print the d2f dx d1, being the derivative of the f with respect to E1. Then surely that will be 0. Yeah, it is 0. But it's printed in the same way, with parentheses around it. But then again, this whole thing prints parentheses all the time. I think something is wrong with taking the derivative of the division, meaning that it should still go wrong if we remove this x. Because the real problem is in the division, I think. Yep, we still have the 0 here. So I'm calling derivative, I'll forget about that part. I'm calling derivative here. And that is, we need a derivative of a division. And function log power, wait, division isn't power. Is it it's a product? I think it's a product actually. Yeah. My division is stored as a product of the numerator times the denominator to the power minus 1. So this is the one that goes wrong. This returns the sum of multiplication of the derivative of argument 1 times argument 2. Excusez-moi, why is that one up front? This is the one that's going to be 0 then. Okay, it might reorder itself, I guess. If we call multiply with an expression that is 0, then it doesn't short circuit to 0. Type 2 is the type of the argument. That would be a constant then. It's not a sum. Wait a minute. If type 1 is sum, is it? Maybe. 2 is sum, no. Result, add, multiply, sum arg1, arg2. It's again a multiply. Okay, I guess I can ignore. It looks like I can ignore the division then. There is something with a constant here. I don't know. It's, the formula is too big, so let's reduce it. We just have to debug symbolic now. It's kind of really super annoying, but yeah, it's the way it is. Just comment these things out for now. What the hell, just remove everything. And then write something that I can debug. So auto, I have some do I even need a function? Probably not. We can use an expression, I think. So I have some expression which equals I'm just gonna go with the simplest thing that might go wrong. So we make an expression which is just a multiplication, and then I'm going to calculate the derivative with respect to something that is not here, aka C1. You'll totally be kidding me, right? So the expression dc1 is expression derivative with respect to c1. Let's print that out. And I stop the music. Well, that just worked. Division. No difference. Okay, let's turn one of these things into a sum. Let's turn both into a sum. Let's make it a function. Everything works. The T of test the derivative as above. That would be E1. It also works, of course. This didn't even change anything. Let's reproduce I'm going to call it F2 though now instead of the derivative. So we're going to have two functions then. Where, well, okay, let's just do everything. As in full reproduction. You try to get to it from one side, but now we're going to try to get to it from the other side. Meaning the whole thing. Yep, there's my 0. Okay, what can we remove now? It's now going to slowly remove stuff. Doesn't matter where we begin, just remove stuff. I don't like this square, of course, so let's remove the square. Wait a minute, the most important point here is, of course, that this thing is not a function of E1. There's no E1 in it. That's why it becomes 0. So how about I simplify it to, well, let's just not go too fast. This is a slight simplification. Just remove one term. The 0 is still there. We can then simplify it again by removing this term as well. 0 is still there. And then we can simplify it even further by making it just a single variable. Zero is still there. Well, there is a 0 here anyway. It's kind of, I don't know. It's not really anymore at the front where it was first. But I think it still reproduces. And then if we divide by that symbol directly, then what happens instead of a function? Now it works. The fact that it is a function is involved. This is a function to the power of -1 because we divide by it. What happens if we multiply with it? So we remove the to the power of -1 here. Yep, still there. So yeah, it's not related to the division, but it is related to the function. Now the other one, it does have an E1, so this can just be removed. The first term is not a function of E1. Yep, still a 0. This has an E1 in it, and the rest also, but I don't think that's... let's remove this. There's the 0. And the 1 also. Wow. Found another bug. And then if you use E1 directly here, the 0 is still there. Okay. And then if we swap these two, well, that shouldn't make any difference. It really should not make any difference. Okay, so this is the multiplication between now a variable and a function. And now we take the derivative. Can I can I print the type of this expression? In full, I mean, like, I don't know, what is it? What support do we have here? Function, expression, is it just a definition, of course? No. So here is how, wait a minute, it is the derivative of a function, but we already short-circuited that. I'm just calling the derivative on the expression directly. Definition being an expression. No, I'm not. I'm not. So this does not have to be a function then. This could be, I think, an expression. Let's try that. Yep, the 0 is still there. Okay. Now, let's try to see if we can get something in the debugger now. It is a product. Well, that makes sense. This is a product. So we take the derivative of a product, and then yeah, we just you add the addition between two things, and one of them should result 0. Now, of course, I forgot which argument was the first one. Take the derivative with respect to E1. So the F2 derivative is going to be 0. That would be the argument 1. That is this one. This is going to be 0. Well, this thing cannot do anything else than just return the 0. but let's try. So I do, how do I know where I end up? Argument 1 is bleh. Argument 1 is here. Step. Okay, so we are in the derivative of argument 1 now. This should return 0. So if this is oh yeah, already, because it is it's a symbol, so that's quite fast. It just says if this symbol is equal to the other symbol, then return 1, otherwise return 0. So this literally returns something that cannot be more 0 than what we have. So this is 0, apparently. Wait a minute, this is 0. 0 expression. So we're going to call multiply with a 0. I'm not sure that is allowed then. Or wait a minute. Yeah, this multiply is being called with 0 and argument 2. And the result of that should be 0. Or it is not allowed, one of them. I don't remember anymore. Step. Multiply. That would have been nice if it just turned on symbolic. Okay, let's try this again with symbolic on. Symbolic. It's not being flushed yet. But okay, in the end it will be flushed, and then at least we get argument 1 being printed. Type 1, okay, it's a constant. In fact, it's 0. And type 2 is a function. Aha, okay. And that wasn't needed. I think it had to be a function. Not sure anymore. I think this is a problem here. That is the problem. I will not recognize what it is. I should get the underlying type of the function if it is a function. Okay, it's not a sum, type 1. See, type 2, if type 2 equals sum, but it's not. But, well, it's not, it's totally not in this case. Because the function is just a variable, a single variable. Yeah, this one, just E6, so that's just a single variable, symbol. So if type is compared with symbol, then we should be alert, but it's not a product, nope. Type 2 is not a product. Is less. Yeah, you're not allowed to make product. You can definitely not allowed to call make product. I remember that one. I forgot which one was the 0. Argument 1 is a 0. I highlighted that one. So is less, I don't think it's less than. Argument 2 is not less than argument 1. Constants are always less than something else. Next, we're here. Oh, wait a minute. We do that one first. Yeah. So the argument 1, which is 0, is a constant. A constant is less than a variable. It doesn't matter what the value of the constant is. So we do get here, and we just call make product with a constant, but the constant is 0. And that's not allowed. But for obvious reasons, and then that should crash, shouldn't it? I mean, either I want to get an assert. Yeah, this is weird. So step, calling make product. Oh, now we're multiplying with 1 suddenly. I thought it was 0. One times F2. Yeah, oh, okay. Yeah. At least here it is tested. It's tested to be 1. I just return arg2. Okay, so you are allowed to call make product with 0 and 1. So 1 times F2 equals F2, which is returned. So the result is now F2. Yep. Okay, I think I see it. It's not really calculating the derivative. It's just stating that you have to take the derivative of f2 with respect to e1. And then during printing, it's printed. It's evaluated, apparently. Why? Maybe full def makes it recursive. Yeah, anyway, it happens in the second call. Well, let's try this again then. So it's addition of something and something. It's the second one that goes wrong for some reason. I thought that was the first one. This is derivative, and then I could put a breakpoint here, I think. No, sorry, this is derivative of a symbol. Step. Finish. Step. Okay, this is the second one. Definition derivative. Derivative. This returns 0. So this is 0 then. And function 82. Yeah, the thing is returning a function. Can't return a 0 function. So the problem is that multiply gets a function, but the function has 0 as its definition. So we have to treat that function then also as 0. So now I do step again. Do I get in multiply? Nope. Where the hell am I in realize? Finish. Nobody knows where we are. Just step. Finish. Step. Finish. Step. Wait, this is the derivative. What am I doing here? I'm just still here, I guess. Derivative. Finish. Now we're back here. Now I go to multiply. Multiply. And now argument 2 is a function that is 0. Next. Print type 2. So type 2 is a function. But how is this thing passed? 69. It's passed as an expression. That's annoying. So even if less, I think should work here. As in, this should be false. Because I want to treat argument 2 as a 0. Yeah, it should not happen. Okay. How to solve this? I think I should just test each argument to be 0, to be a 0 function. And if that's the case, then return 0. This is a super special case. Not call make product and then rely on that. Otherwise I have to fix the is less than as well, which I don't like. Okay. Well, where do I go to? This product multiply, I think. Holy moly. The keyboard made noises. Or function const reference. How the hell do I get the definition? Definition. Right. How can I return 0? That was the hash cached 0, right? That was the name, I think. Hash cached 0. Constant is also a constant. So this deals with multiplying with 0 if the 0 is a function. That is 0. Now normally, what happens if you just multiply with 0? Then it would not be a sum. Type 2 is not a sum. It's not a product. It's not a product. Then we get is less than. The arc1 is less if it is 0, for example. So then we do rely on make product. Just call make product with the 0 up front in that case. So now arc1 is 0. And then, yeah, just arc1 is returned. But then, if we want to rely on this, then make product should work as well, I guess. If I just pass this with where argument 1 is a 0 function, then it should kind of do the same thing. Can't totally, I don't know. Adding it here is kind of, should add it to this function. It's multiplying with 0, that is the problem here. So I would have to check is 0 on argument 1. Could even extend then to, I could say that is constant is 0 should work on a 0 function. It should return true, but then I don't want to return the 0 function, to be honest. Yeah, it's like the test is literally comparing it by pointer, so I might as well pass here constant as cache 0. So that's what it is. So at the very least then maybe I should have here and test that the argument is a 0 function. which means that, well, 1, it is a function, and 2, it is, the definition is 0. I guess we can do that like this. The type equals function type, and static casting that to a function. Getting the definition. Then gives me something that is 0. And now we definitely have to fix less, because otherwise we would not even get here, and assert on this assert as well, if we would get here. So if this is the case, then also it should be treated as a constant. See, if you look at this, it's kind of weird. It demands that argument 1 is not a product. So then what if it is a function which is just simply a product? That's still... well, the function is treated as a symbol, but a symbol with an expression as definition. So it kind of sucks that I would have to make a exception for being 0. Well, for the rest, I'm treating it differently. I mean, there's another one here. Might as well add that one as well then, right? So if argument 1 is 1, or all of this, and it is, the definition is 1. So that would be the same thing. But now constant is 1. And then this is for a product. And then of course you wonder, yeah, but shouldn't I just, you know, have this return true if argument 1 is a function, which is has a definition which is 1, because this is being used in a lot of other places. Well, is 1 maybe, no, is 1 not, but the 0. So you will make a sum. You do a plus some function, and that function is a 0 function. I don't want to see the sum back. It just really should disappear. So this should by itself already return true. If argument 1 is a function that has a 0 definition. So maybe I should not add it here, I should add it deeper, which means that this thing has to be changed from the simple thing that it is to something that we can't even define in the header anymore then. And I still have to fix is less, either way anyway. So this means that a function that is a zero function, so to return true for is constant. And we have to fix the is less exact. I'm gonna make a virtual function, I think. Call him. So now the zero function is going to return true for is constant. Okay, then the zero functions are treated as a constant. Yay, this works. And is less exact still has to be fixed. Arg1 get base. What the hell will that return? For a function? Probably just a function, right? Get base expression, return this. This is for expression, that's the default. So probably power, yeah, power is all loaded. So it just returns the function itself. And then there is less exact. Yeah. To add a special case here. Type is constant. What is that? Type then, man. Type. Yeah, type of argument 1. Oh. Nope. Just do that later. It's less exact, needs to be fixed. Okay, I lost it. I forgot what I did. Okay, so now zero, a function that has a definition that is a zero, is the only expression that returns true for a zero function. Yep, this is a function that returns true if the definition is zero. If the function is defined as a function that is defined as zero, then it doesn't work, but I'm not ready for that yet. It's it means that is constant now also works for zero functions, which is halfway making is less working. Yeah, I would say that is zero. That would be really nice if that just worked. It's just used already in a lot of places. It just should work. I should not add this. This thing should return true for zero functions. It's just the way it is. And if I do that, then we should not have to do this. Because then the logic that comes below that should already work. It's just then the function is then simply treated as a constant that is zero. Either that, or I have to change every place where the zero is being used. It is not that much actually. LOSCBD. I'm going to remove this. And this. Uh-oh. Infinite recursion. Fuck. Or not. No, I'm calling it on the definition. This works. Yeah, no, you. Yeah, the other ones as well or not? It feels like not. But it's kind of weird, of course. So I'm like literally treating them now like a function that is defined as 1. It's just 1. So why would I not treat it as a constant then? But yeah, if I define it as 2, it's not treated as a constant, you know. Okay, I have good hopes that now we will assert instead of printing a 0. From wherever I was testing. No, it's still just printing a 0. How the heck is that possible? What's a pointer? It's a pointer. Damn right, that is 0. That is true. We are back at derivative. We just returned from this derivative, which returned 0. So it returned a function that is defined as 0. So now we get into the multiply. This multiply is that one. And then the argument of type 2 is there's a function. Yes, yes. Next. It's not a sum, not a product. And now is less should return false because wait a minute, what? Multiply, this was a 0. The argument 2 is 0. I can even print it here. Is 0 function. Yes. Argument 1 is not. This means that argument 1 is not less than argument 2 now. Let's just test it. Step. How step brings me to what this is inside is less. Yeah, what? Oh, the constant expression. Argument 1 is constant. No. 2. Next. Yes. Step. Oh, I didn't fix the is less exact. Yeah, so I still have to fix that one. So this is probably not working. Yep, it's returning true. Which then means that we get here, make products with where argument 2 is a 0 function, but that should have asserted. Pretty sure about that. This should assert. Because arg2 is less than. This is now a 0 function. Still. And argument 1 is not. Oh, the same thing. That is the same thing. Yeah, never mind. So this is still true. And then we get argument 1 is not a 0. It's also not 1, is it? And then we simply realize it. Yeah, because argument 2 cannot be a constant. Because then it would have been the first one. Okay, so we have to fix it is less exact before this is going to work. Okay. This function is super difficult. Oh, I see. If the type, but no. trying to understand this. So type is argument 1, and then we assume that argument 2 is a constant. What? Why is that? Oh, because they are not unequal. So if one of them is a constant, then both are a constant. Yeah. Okay, this deals with equal types, this part. I really should treat this thing as a constant, right? Expression type. This is very complex. I vaguely remember that this was very complex. Binary op. Binary op. So normally I think a function type is ordered after symbols and after constants, of course. So you already have to change the type into a constant if it is a zero function at the very least. Yeah, this part would work. So bloody head on this. Oh, we have function included. Great. So you can just set a cast this to... No. We don't need it anymore. I can call... arg1 is 0 function. Is type a Wordle function? Probably not, huh? Totally is. No. Might as well just call one Wordle function. So if argument 1 is a 0 function, meaning it's a function, and it's 0, then I want to set type to constant. Treat it as a constant. Same thing for argument 2. And then this part works now. But this doesn't, because here we are casting it to a constant, which is no longer very correct. I could set argument 1 and argument 2 to the definition instead. Then it would work. Yeah, let's do that. Which is not possible because argument 1 and 2 are references. So we're going to have to change that. Let's make an argument 1 pointer. And an argument 2 pointer. And then we work with the pointers instead. Change it to VS Code shit. No, thank you very much. Vim is the way. Vim is the only editor for real coders. Real coders use Vim. I think I have to do this. No, if it's a symbol, I didn't change it, so I might as well use arg1 and arg2. So I'm dealing with same types, and if it is not a constant, then I definitely did not change it. So I only need to use the pointers here. And we have to change those if this happens. Well, maybe anyway. Well, not maybe, just change it. So argp is. So now we need a pointer to. Oh, come off. Oh, really? You make me nauseous. IntelliSense. That would be a reason to not use it, yeah. Cluttering my screen and stuff. And the only thing I heard about it is people complaining that it is so slow. Type something and have to wait a whole second before something pops up. IntelliSense. The name only. I mean, it's one of those dirty fucking Microsoft names. The people that come up with that. Yeah, other people claim that they are that they are aesthetic by how the AIs are helping them. Reference to type const expression could not bind to an R value. Really, I'm quoting here, Demir, and the only problem that I have is the code and the algorithm. I don't even notice that I don't have IntelliSense or something like that. No, you're saying that it helps you a lot. Well, other people say that AI is helping them a lot. So it doesn't tell anything about IntelliSense. It tells something about you. The type is wrong. That would no, yeah, never mind. Okay, so it seems to finally work now, because what is this? It prints F2. Yeah, F2 is E6, I know that. Is it this 0? God. So unreadable. Now here you see that it is short circuit. I think this is the output on F2. I'm gonna go back to the source directory, edit epsilon something, Newton-Epsilons T. It's T is the derivative of G. I don't have a G anymore. G is an expression now. Yeah, so we just get F2. F2. Yeah, that's more than a year ago or 2 years ago. How long is it? Stop talking about Vulcan. This is shitty music. Okay, this is slightly better. F2 is E6. That's true. But the whole point is, of course, that the result is F2. Okay. So if we take the derivative with respect to E1 of this expression, then the result is F2. That totally works, right? That's what you wanted to see. And I'm going to replace this with a function. More or less the same thing. And now we get 2 parentheses. What the f... I think this parenthesis, it just puts parentheses around if the full definitions of functions, I think. So these parentheses belong to the fact that this is a function. And then that function has as definition another function. And that function has a definition E6. I think that's what is happening. Maybe I should make it a little bit more clear. So instead of printing parentheses, I should maybe print the name and then the definition. Or add another I/O manipulator. Okay, right now I need the name anyway. So let's print the name, followed by a colon and a definition. And maybe I hesitate to use this one. Let's use some other thing. I'm gonna use an UTF bracket, I think. I don't want to be bothered with brackets. What the hell? There we are. which brackets would be good for the definition of a function. I like this one. Yes. So now you see where the parentheses came from. So this function, which is the derivative of g with respect to E1, and then that is repeated, is actually equal to the function f2, which is equal to the variable E6. And that the reason that this is the case, of course, is that g is defined as f2 times E1. As you can see there. So now we go back to this code. And hopefully magically see that the 0 has disappeared. Nope. Let's crash. On the other hand, the 0 has disappeared, but let's see. G is apparently equal to, well, apparently that is in fact it's equal to x minus the derivative of f with respect to x, which is C1 times E6 plus 2 times that plus 2 power minus 1 times f. Aha, and f is this. Yeah, that is true. At least that this is f. I think it works, but the crash is suspicious. So I'll have to run this in a debugger again. Yeah, I suppose an arc2 is a 0 function, right? I mean, it's the only thing I added. Ish. Yeah, well, you can't cast it. Worse, the result is going to be 0 then. Definitely kind of weird, yeah. Which one was it? This one? Oh, okay. It should be false. This is true. And then we try to combine that. We should return 0 then. I guess. Yeah, the thing has its own way to detect if something is a constant without really testing if it is zero. But yes, grab. Okay. The other one is a constant. Sorry, what? The other one is a function. Confused. I am confused. Did another combine? No. It's here. It's happening here. The arc1 So I was not a constant. Okay, so yeah, if this is a constant, then the other one is also a constant, but it could be not a constant. It could be a zero function. So I guess I'll have to do that here as well then. Right, so now the result is this minus the derivative of f with respect to x to the power minus 1 times the derivative of f with respect to e1, which is this. Yep. Yep. Okay, so g is defined as this, x minus the derivative of f with respect to x. And then we take the derivative of g with respect to e1, and then we get minus this derivative divided by this derivative. It looks like it. Is that true? No. I have no idea why that would be true. Does it look like it should be true at all? This is also not true. Something is missing here. Why? Oh yeah, that part is missing. This derivative here runs still here. So it is actually f divided by this derivative. This f runs still here. Yeah, that's what it should be. So g is equal to x minus f divided by the derivative. And then we take the derivative with respect to e1 of this, then, well, x is not depending on e1, so it becomes 0. You are left with a minus sign. Oops, and we take the derivative with respect to f. And this is just a constant, because this is also not depending on E1. The derivative is not depending on E1. That is correct. Good, it finally works. So I guess I fixed the symbolic now. I can concentrate again on what I was working on. And we'll leave that. So I'm going to take 2 more derivatives. And that is 0. It feels like if I print G, either well, if G is G, okay. But if you want to have the full definition, I don't really want to have the definition of the other functions, do I? I mean, this is unreadable, while there is still information in it if you read it as x minus, yeah, but that would be just the definition of G. Yeah, that is, like literally. You have divided by that. Tempted to put that stuff on a different line, really, but it would just easier to, I don't know. I want to copy and paste this definition to octave, right? So what do I leave out then? The names, to everything in front of the columns. That's why the parentheses should have been there. Yeah, what to do? Where did my octave go? Oh, it was somewhere here, I think. Somewhere here. Just here's an octave. I suppose my G is still good. So we have the derivative with respect to E1. And now we want to have the this thing. Which is the derivative of that one, the relative to C2. And then again C3. Doesn't look like 0. Nope. Uh-oh. Did Octave already fix this bug here? I reported it. You know what, maybe I should just do a simplify. Simplify, because the derivative is not simplifying anything. It just, damn it, still not 0. Okay, let's do it again then. F. Did I define an F here? I defined G directly. F equals this. And the df equals then this. Then G equals x minus f divided by df. And then I want to take the derivative with respect to E1, C2, and C3. So simplify the derivative of G. Sorry, derivative of the derivative of the derivative of G with respect to E1, C2, and C3. Yep, that's the same thing as you already had here. Totally not 0. What went wrong? No, damn it. Yeah, just totally. This is not zero, of course. Let's have a look at this derivative again. So that was this, which is hopefully correct. What am I doing here? Is that the same thing? So we first have the power to -1, that's the bottom. And then we multiply that with this, which is C1 times x plus C2 times x squared plus C3 times x to the power 3. So yes, except for the minus sign. So then this whole thing is divided by the minus sign apparently. What is a minus in front of it? It's not particularly... Well, okay. The minus sign here was put in front of it. That's correct, yeah. And then this part must be equal to what it says here. C1 times E6 plus 2 times C2 times E3 times x plus 2 times C2 times E7 times x plus 2 times C2 times E8 times x plus 3 times C3 times E6 times x squared plus 3 times C3 times E7 times x squared plus 3 times C3 times E8 times x squared plus 3 times C3 times E9 times x squared. So yeah, completely correct. And if then you take the derivative with respect of that, let's just assign it. So this would be the dg something. dg/de1. And then we do the dg de1 C2. Divide diff, that thing, C2. Display. That's a big thing. Yeah. Oh, it's not zero. So this is an interesting one. Apparently the derivative of f with respect to E1 and then C2 is just x squared. Now, so that means that we would have, let's say, an E1 and a C2 factor only together with an x squared. Now there's no E1 here, there is a C, there's no C2 here actually. There's an E1 here but no C2. C1 times C2 times C2 times E1. Yeah, so this is the one. That gives us an x squared. C2 times E2, C2 times C3, C2 times C4, C3 times, and so on and so on. So this looks totally correct. And then we have the then that should be divided by this. Which apparently is the minus the derivative of f with respect to x. I can't read all this. I'm going to ask AI to figure it out. So failing in punctuation here. think this belongs together. And then C1, so this belongs together. And this, yeah. Yeah. derivative of that with respect to C2 gives us this should be 2. There's a 2 here. Okay, I can't follow it. What the hell? What nonsense. Yeah. We have a power of 3 suddenly out of nowhere. What the fuck? Yeah, wait a minute. It's just x times that one, yeah. No. Huh? What's the derivative of this thing? Is... Don't rely on AI to do anything, let alone mathematics. So no, this looks actually, this looks correct. Actually, I thought it was a minus sign too many, but do you have a minus sign here and a minus sign here for the derivative? So you already have a minus sign. Now I take the derivative with respect to C2 of this thing. So x2 is just a constant, which remains. And then we get the minus in front of it, so that would be that minus sign. Of this minus sign is that minus sign, I guess. And then this minus 1, because that minus sign becomes a minus 2, and we have to multiply it with the derivative of ax with respect to C2, which indeed is this, times another x, which it filled in here. So this is correct. But then I just make it equal to this, so that it would be equal to my formula. So that step is wrong. Now so the minus sign here indeed drops out, and then we get ax to the power minus 2 times 2 times the sum of those things times x to the power 3. Yeah, this is correct. Octave, which does not make any errors, is dividing by something to the power 2. So this something should be ax, which is given here, which is something that begins with C1 E6, yes, plus 2 times C2 E6x, 2 times C2 E6x, plus 2 times C2 E7x, plus 2 times C2 E8x, of course, and then 3 times C3 times x squared, and we have 4 terms, 6, 7, 8, 9. 6, 7, 8, 9, yep. So this is indeed a squared. And now this should have a factor x to the power 3 in it. I'm not seeing that one. Well, it just doesn't, does it? Actually, this is the same as what is here, but then with a minus sign in front of it. So it's x squared times minus the ax, which accounts for these things, and this one, and 1 of 3, 4 of those. Plus 2 times this times that. What? Yeah, I disagree with the simplification here. Just Octavius did not simplify it very well. Maybe you should try. If you multiply this one out, it gets better at it, maybe. So this was a squared. Let's define a. So ax is sure, c1 times e6 plus 2 times g2 times e6 times x plus 2 times c2 times e7 times x plus 2 times c2 times e8 times x plus 3 times c3 times e6 times x squared plus 3 times c3 times e7 times x squared plus 3 times c3 times e8 times x squared plus 3 times c3 times e9 times x squared. That's the same as this. 2 times plus 2 is 7 and 2, where are we? 2 c2 3 6 7 8 and 9. Yep. So this is the same as that. So we take this thing here. I'm gonna use this. H is this times ax squared. And I'm going to do simplify expand h. See, it had totally failed. Totally failed. You do simplify here and then you get this shit. Well, actually it's this, which is way simpler. But still not power of 3 here. No x to the power of 3. And this looks like yeah, no, it's fake. Okay. Yeah, well, it looks like the derivative of a with respect to something. No, it doesn't. Possible. Cannot follow it. Yeah, I have to go to bed. Just not working today. I don't understand it. So, okay, to summarize anyway, the problem is that I get something different with Octave and with my program. And also with Claude, but that's not really a problem. Now, Octave should not make any errors, but on the other hand, why would my program make errors? I mean, at the very least, I want to really see the difference in. So g is defined as x minus the derivative, sorry, the f divided by the derivative of x, of f with respect to x. But this is just a name of a function because this one contains E6, E7, E8 and E9, while f contains E0 all the way up till E5. So they are basically completely different functions. Even though this one's named like that. And then if you take the derivative of g with respect to E1, then my program produces the same formula as Octave. So that one should be okay. And then we take the derivative with respect to that of C2. With respect to C2, I mean of that. And then I get something else. Why? Let's just do it manually. I'm going to do it manually. So like I said, if you just take the derivative with respect to E1, then it worked. This is the same as what Octave gives me. I can't jump to the opposite parenthesis. I should do it in two parts, I suppose. This is defined as, let's do it like that. Okay, I put everything back. Maybe not that. So on one hand, this is colon definition, and the definition ends here. So we have to delete all of this. And the to the power minus 1 then applies to this thing. Times that, which has a simple definition. So we can remove the definition and the column. Oh, well, might as well remove that as well. And then maybe write it a little bit nicer, as in we just divide by this. Where note that g was defined as x minus f divided by this. Yep, so that's totally correct. And in formula form, let's remove the names. And then I should make this normal parenthesis really. where I just filled in what that is. And also this one can be written differently then. Let's put the minus sign first and then this. And then we divide that by, now the minus sign has been done. And let's jump here, remove all of that. And this as well. And this. And that's what we divide by. And then let's verify that this is indeed correct, which can be verified from not using the derivative, I think here. Just use some other function. I'll just call it df, but really it's just another function now. And we define then those functions. So f is okay, that's a good question. Notice we have f here. df. And then we can do, we start over here, octave, add all the symbols, F is that. Syntax error. And that probably also won't work. So that would be equal to this. So that is minus C1 times x, minus C1 times x, minus C2x squared, minus C2x squared, minus C3x to the power 3, divided by C1 E6, and then 2 times, 2 times C2, E6 plus E7 plus E8 plus, that's it, 6, 7, 8. 2 times C2, 6, 7, 8, 3, that is 6, 7, 8, 9, all times x squared. So that is the same. Yeah, I would say no way in hell that Octave makes an error here. So if we get the derivative of this with respect to C2, which I have been doing all this time, this dg1. No, I already have that, but this one is simplified. Let's define it as this more simplified form. And then take the derivative of that with respect to C2. I'm going to assign that as well. As long as this is a name, dc2. And then do simplify expand again on that thing. Okay, I haven't seen one this big in a while. I should have multiplied this thing with ax first, I think. Square even, or... This is... Yeah, I don't know. What the hell? Mm-hmm. Yeah. Yeah, this is correct. Not simplified, but that makes it actually easier to see that it is the correct derivative. So this whole thing here is, well, this plus this is ax, and you see that again here. So we have minus x squared divided by ax plus something divided by ax squared. Where this then in itself is the derivative of well, this should be the derivative of the ax, and then this is just what we had in the numerator. up here, this part. That's what you have here. So yeah, that's it. Now I used to have defined the AX, which is this thing. Can I just copy that from Claude? No, not really. Beautify my ass. It's something that ChatGPT is definitely better in. Writing formulas, but then still you can't copy them, so yep. No, because this is AX and this is AX squared. I'm just going to multiply the whole thing by AX squared, right? So my derivative multiplied by AX squared is really this. I mean, I can take this as a fact because Octave doesn't make any errors. And then I'm going to try to reproduce this formula now with my program. So we take the derivative with respect to C2 as well, and I want to multiply it with AX. Let's just multiply it times AX squared. Oh, that doesn't work. The powers, I mean, this power here is, of course, actually an XOR. So the what is it? The ordering is not correct. You have to put it. It's too low. It's not a power. It's being done way too late if I don't put parentheses around. And then here we have the same problem, I think. think it might not have simplified it because it doesn't like to simplify formulas. Functions, I mean. So if you really want to know what this is, I have to copy it and then assign it as an expression. I don't understand this. Oh, I'm making it same here an expression. So this returns a function, and then the function is multiplied by ax squared. Yeah, this is not going to work. I should probably do... I can detect the definition of the function. It's maybe better. Definition. And then again, take the derivative and then the definition. Definition. Okay. So that's an expression, and then times the squared is still an expression. Let's see, and g is a function, but I can just take the derivative of that. So function, the derivative of a function is a function, yeah. So maybe I should just take the definition right away of the function that I have here. I think that derivative of an... can I take the... Of course I can take the derivative of an expression. So I do definition of g, and then I take twice the derivative. It should work. It should be just an expression. So no, it should not have any variable names at all anymore, right? Still have variable function names all over the place. Why? Oh, the definition itself has functions in it. Ugh. So I'm basically not happy with my functions now. I have to get rid of all the functions. Function. I don't want g to be a function. Okay, what the p. G must be just an expression without a name. And I'm gonna use the definition of f and the definition of df. Yeah, if now it works, it doesn't mean that there wasn't a bug in it while using functions, of course. But okay, let's first see if this works. No, g is not a function anymore. Just take the derivative. Oh, this is g, I think. Yeah, it's just a big thing. This is g, and now this is that derivative. Times x, gx squared. Well, at least it is small. So this should be equal to this. Yeah, that's x squared times something. I think it's correct. C1 times E6 times x squared. Plus 2 times C1 times E7 times x squared. Plus 2 times C1 E8 times x squared. minus C3E6 times x squared times x squared. So, yeah. And then again for C3E7 and C3E8 and C3E9. And then out of nowhere we get a second equal. What? I'm printing it twice. It's just bullshit. Okay. Now that works like a charm then. Or rather, this way it does work. So yeah, I'm just printing it twice now. Yeah, I'm definitely going to bed now. So you have to I'll revisit tomorrow why it looks weird when I use functions in between. I think the simplification is just not really working in that case. The function is treated like a symbol. So even if, so say, if you have two functions and the one function is the negative of the other function and you add them, you don't get zero. You just, it doesn't simplify that. No, yeah. I probably should the whole idea. I mean, I can't remember anymore why I used functions in the first place. Right here, I could just work with expressions, couldn't I? Can't I? Definitely for f itself. I mean, even this. I think I can just do this. It's no longer a function. This looks suspiciously much like df. No, it's just df. Hmm. Good. Yeah, and then in the end we wanted to get a derivative with respect to C3 as well. Oh, what the fuck? And then you get this. Yeah, no you don't. We had this. Then the partial derivative with respect to C3, 0, 0, 0, there it is. We should get that minus that minus that minus that, and that's it. It's almost nothing. That's what we should get. Not this. So this might be failing a simplification again. Talking about we need simplifications. So the whole function really doesn't work, does it? I'm not working with the function though. I'm adding the definition. These are not functions. I'm adding that to a function, but I want to take the derivative of the definition again. It should be an expression. Maybe you have to multiply 3 times with this to the power 3. Uh-oh. Nah, come on. Why? What? Okay. Well, at the very least, if I take the... If you multiply this first with the derivative squared, and then we take the derivative of that, then we do exactly what I did before. This should be simple. Yeah, and I'm still printing it wrong. Let's stop printing it like this. Yeah, whatever. So you know something simple. Really? Nasty. Yeah. Yeah, well, okay. Does he have anything? That is the question. Or can I take the time to do 6 knight moves? I'm gonna try it. Oh, I wanted to avoid this exchange. Damn it. Could have gone here. Didn't want that, so I thought I go here, 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 here. But he can still take me when I get here. Okay. He's probably going to attack my pawn with the queen. Can defend it with the king. Yep. Can defend it with the rook now. What? That makes no sense whatsoever. No, that's a good night. Good night. Bishop here. I don't like that. Yeah, being 1 point down, I'm not going to do anything. I'm just going to have a look. Can he attack something here? All files are closed. This pawn is a bit weak. He could go here and then attack it. But yeah. For the rest, just do nothing. He wants to push this. Let's go here. I wanted to push that one. It is a double attack. I did not see that one. Maybe I should take some initiative instead of doing nothing. Oh, he closes it again. That's weird. I'd say he just has to play this. Why not? Oh my god, he's coming. Coming in. Run. Okay, I'm gonna go here and then I lose that ball. Shit. Yeah. Good move. Could go here. Should I just run away like this? Seems to make more sense. Yeah, the rook is going to be played, but as soon as I play it, he's going to take this pawn. Nobody likes that. So I can't play this rook. I can't play anything that looks like it. That isn't a move that you want to do. Oh, he's going away. The queen can still come in over here. Well, not any longer. No. A pawn is a pawn. But theory is equal now. So that's good. I'm about to lose my knight. It's defended. Soon my king will be safe. Oh shit. I think it's time to give away this pawn here for king 70. Or I just push it. I just push it. If I take now and he gives check, I can't give check. He just can't give check. Fuck. The queen is attacked. If he takes here, then he can take there with check. And then there. That would be all very nasty. But, well, not anymore, I think. Wait a minute. Yeah, I can do this, right? +3. And let's run away. I'm +3 now. Wow. Oh, it's infinite check. He doesn't want infinite check. This guy is completely insane. Let's figure out what to do here. He can give check here, damn it. Okay. Finally. And winning. Ooh. Ridiculous game. Yeah,